Okay, so last week we introduced the idea of acid rain and acid rain contributing to um, some effects on society and the environment. Now we're going to get more into the actual chemistry of acid rain and the chemical reactions that are taking place. So let's start off with where acid rain comes from and what is acid rain. So we see in this image that it's going to start over on this side right here. And in this image, what we have are some gases that are being released because of the burning of fossil fuels. So most of this is actually coming from your factories that are burning fossil fuels in order to create electricity. But it also comes from cars and trucks as they burn octane in order to move. Um, Some of the gases that are released, the important ones that cause acid rain, are going to be your sulfur dioxide, uh, carbon dioxide over here, and nitrogen dioxide in the middle. So SO2, NO2, and CO2. CO2 we've talked about before, but we haven't really talked about the other two. Um, these are going to start the chain reaction that will cause the acids and the acidic conditions. Okay, so in this diagram, what we see next is that these gases, and it doesn't show the reaction here, but these gases are going to mix in the atmosphere and with other components in the atmosphere. And eventually, through some chemical processes that we're going to go through in a moment, they actually combine with the water vapor, the moisture in the air. And it makes the water slightly more acidic. Okay? Not a lot. It's not like the rain falls and burns your skin, but it's just slightly more acidic. That more acidic rain falls onto our buildings and onto our trees and into our soil. Okay, so now let's go through some of the reactions that we're talking about. Okay, so we're going to look at some of the equations and reactions that are taking place with acid rain. Again, we're leaving out CO2 because it's not actually a significant part of making the rainwater slightly acidic, at least not in the atmosphere. So at first we are looking at formation of sulfuric acid. And initially, we have this sulfur by itself, and that sulfur is going to be coming from the burning of fossil fuels. So some of those fossil fuels have a sulfur component to them. And that sulfur component is going to mix with the oxygen uh, that's part of the combustion process. And through that reaction, we're going to get sulfur dioxide. Now, the sulfur dioxide is going to go through a couple of more steps where it mixes with oxygen again. And this is happening in the atmosphere now. So now we have our sulfur dioxide mixing with oxygen in the atmosphere and water in the atmosphere. And when it mixes with the oxygen and the water, what you end up with is right here. And this is the actual sulfuric acid. It's the sulfuric acid, this H2SO4, that is going to then make the rainwater or the water vapor in the air slightly acidic. Okay? This process of um, reacting with water, putting a water molecule basically into the reaction, is called a hydration reaction. Let's see, hydration reaction. I'm trying to do that with the mouse pad. Okay, so there weren't too many steps actually involved in the formation of sulfuric acid. But when we look down at the next one, the formation of nitric acid, there's quite a few more steps involved. So the NO initially here, um, you're going to see it start to go through several reactions. But the big thing here, the big part of this is that we keep adding oxygens on. So we have NO, the next step we're going to have NO2, and then eventually we're going to have NO3. And then finally, after our hydration reaction where it combines with water in the atmosphere, we're going to get our actual nitric acid here, which is HNO3. The 2, remember, is just referring that there's 2 moles of HNO3 after this reaction. So initially we get these gases through combustion of fossil fuels, and then those gases react with water vapor in the atmosphere through a hydration reaction and give us our nitric acid down here and our sulfuric acid up there. That's what creates the acid in the water, making it slightly acidic. Okay, so now I want to go over a few facts about the gases that are released during this process, so especially at factories or power plants, I should say, power plants that burn fossil fuels for electricity, to make electricity. I mentioned that CO2 is not a significant contributor to the formation of acid rain, even though there's a lot more CO2 in the atmosphere than there is sulfur dioxide or nitrogen dioxide. CO2 doesn't have a big impact. So as far as the acid components, 25% of the extra acidity is going to come from nitric acid, and that is the HNO3, okay? 75%, so quite a bit more, is actually going to come from the sulfuric acid. And we're going to focus a little bit more on the sulfuric acid and the reactions with the sulfuric acid. They have a bigger impact on the process of acid rain formation. Now, of the extra sulfur dioxide, so that's the SO2, which will eventually turn into the sulfuric acid, of the SO2 that's in the atmosphere, 80% of that is coming from combustion, and that's happening at factories and with cars, okay? So 80% of all that sulfur dioxide in the atmosphere, and you can see in this image, it's saying 75,000 pounds of sulfur dioxide released during this refinery accident. 80% in the atmosphere is coming from us. It's coming from human-created processes. Okay? Now, that can mean in a normal, natural, non-polluted setting, your concentration would be very small. It'd be 0.01 parts per million. So that doesn't even mean there would be 1 part. It'd be 1/100th of 1 part per million. Very, very small amount of the sulfur dioxide, which leads to sulfuric acid in the atmosphere. However, in a polluted area, an area that's producing a lot of this gas, it's much higher. It's in the range of 2 parts per million. That is over 200% more sulfur dioxide in the atmosphere because of the pollution that's added by human means, by combustion, okay?